Hey Trig, this is the video for section 10.2, but it is the second half of it, so this is part B. And I think we left off with example 3, and this section is law of signs, so I'm going to write the formula up here. It's off of the front side. Sine A over A equals sine B over B. And that doesn't necessarily mean that A is A and B is B. It's just those two variables that they have named. So this is kind of what we're using for the rest of the section. There is a couple, well, there's one exercise that I'm going to, or example that I'm going to skip here in just a minute. But we'll do example 3 and we'll see how it comes out. So what we're trying to do is an airplane A takes off from carrier B and flies in a straight line for 12 kilometers. So we know that this guy is 12. At that instance, an observer on destroyer C, located 5 kilometers from the carrier, notes that the angle determined by the carrier and destroyer, the vertex, the plane, is 37 degrees. Okay, so this is the information that we know. How far is the plane from the destroyer? So we're trying to find B in this case. They have this labeled as capital B, this capital C, and this is capital A. Okay. All right, so now if I'm trying to solve for this side B, what I really need to know is the angle that's opposite that B, because I can't solve for little b unless I know capital B. Okay, but I don't know capital B right now, and I can't figure it out until I know capital A. So what I can see here is with this triangle, I have 37 degrees here, and I have his opposite, which is 12. I have 5, and I can find his opposite of angle A, and then as soon as I found angle A, what I can do is I can use that information to solve angle B and so forth. Okay, so we're going to have to do this problem, a couple different steps to solving this problem, but here we go. So let's start doing that. Let's do 37 and 12 go together, and then 5 is going to go with this angle A here. Okay, and we're going to set up our law of sines. All right, I'm going to go all the way over here. Okay, so we have sine of an angle over the side opposite. The only angle that we know is 37, so I have to use 37 somewhere. Okay, and then that side opposite is going to be 12. Okay, and then I have sine of A over 5. Okay, so I have those two things that are opposite each other, and what I'm doing is I'm trying to solve for this guy first. Okay, so I want to cross multiply. So I have 5 sine of 37 equals 12 sine A. 5 sine 37 equals 12 sine A. And what I want to do is I want to get A by itself. So we did kind of an example like this yesterday that ended up not actually coming out with a solution. But we're solving for A. I'm going to divide by 12 here. Okay. And then that's what sine of A is. Okay. So sine of A is going to be all that stuff typed in. Make sure you're still in degrees when you're typing this in. 5 sine 37 divided by 12. Okay. And I got 0.2507. Okay. That's what sine of A is. So if we want to get A by itself, we have to take the inverse sine. And second sine of that answer is going to be 14.52. Okay, so A is going to be 14.52 degrees. Yeah, 14.52 degrees. Okay, so him right here, 14.52. Okay, and then what we can do is we can use that to figure out what angle B is, and then solve for little b, which is really what we're trying to get to. Okay, so if I kind of have a mess going on here, so hopefully you can still read this, but 37 and 14.52, I can put those together and then solve for what angle B is. Okay, so I'm just going to do 37 plus 14.52, and then 180 minus that answer, and that gives me that angle B is 128.48 degrees. Okay, that's what my angle B is, and now I can solve for capital B, or lowercase b, I'm sorry, lowercase b, by just doing my law of sines again. Okay, so I want to still use this 37 degrees rather than using the 14.52 because this guy is rounded. So I'm going to do sine of 37 over 12, and then I'm going to do my b So I have sine of 128.48 over lowercase b. Okay. All right. So when I cross multiply this, 12 times sine of that number, okay, is going to be equal to b times sine of 37. All right. Rather than writing all of this out, if I cross multiply these two and just divide by sine of 37, that will give me what b is. Okay. If you have to write it out, go ahead and write it out. But I should just be able to multiply these two together and divide by sine of 37. So I'm going to try that and see if I can do that all at one shot. Okay. So 12 times sine of 128.48 divided by sine of 37. And I get that b is going to be 15.6, and 15.6 should be my final answer, but let's look and see what units we are in. Should be kilometers, so they are 15.6 kilometers apart. This, whatever, the airplane and the carrier, or the destroyer, I guess, the plane and the destroyer, 15.6 kilometers apart. Okay, all right, now in example 4, this one is, solve the triangle ABC. All right, so here's the deal with this one. What we have going on here is, I went ahead and put this triangle down here in the bottom corner because this is going to be one where there's going to be two solutions happening. And so you really have to be careful because they want us to find they want us to solve for everything that's not already there, but we need to have for both triangles, okay? Now, let's check to make sure that we are, in fact, supposed to have two triangles here. We know that if A is less than 90 degrees, which it is, 35 degrees is what angle A is right here. And then we check A in comparison to B times sine of A. Okay, so if A is 7.5 from here, B is going to be 12 times sine of 35. Okay, if I check 12 sine of 35, I get 6.88. Okay, so I have 7.5 here. That is greater than 6.88. Okay, so if we go back to our flip chart on the front side, or our kind of flow chart here, I guess, if A is greater than B sine of A, which is the scenario that we have, we're going to have two solutions. Okay, so this is going to give me two solutions, and now I have to figure out what those solutions are. All right, so you can kind of see how this diagram plays out down here, where we have A and B and capital A. So this is a 35-degree angle. 12 is what B is. And then capital A is 7.5. So we're saying that that 7.5 could be this side right here, which makes this overall big triangle from here to here to here. Or we could have that 7.5 side swing in and make this triangle here. Okay, we could have that scenario happening. All right. Where we have the smaller triangle. Okay, so we're going to do kind of this a couple different ways, or a couple different times. We're going to have a couple different sets of ABCs and ABCs and all that good stuff. Okay, so here we go. Focus here. Okay, I'm going to label these out into, this is going to be my big triangle. Okay, I'm going to label the big triangle with the purple one. Okay, and then I'm going to do a small triangle with the green one. Okay, so I have an A, a B, and a C, and an A, a B, and a C, and then I need A, B, C here, and A, B, C here. Okay, so I'm going to label each one of those out. And we know some things about each one. We know that capital A is 35 degrees. Okay, we know that lowercase a is 7.5 for each one, and this guy is 12. Okay, so capital A is 35, lowercase a is still 7.5 here, and this guy is 12. Okay, and then we have to figure out how those two things are going to compare with each other. They do give us some information that we haven't yet found, so like we should eventually get to the point where this is 113.4 degrees. This right here is 66.6. I'll show you kind of how they get that. Okay, so let's kind of see how this fits in here. Let's do our law of sines with the A's and the B's that we have already and see where we get to. Okay, so we have an angle A that we can do sine of 35 with, and we have side A is 7.5. Okay, we can put that over that. Okay, and then I need angle B, but I know that side B is 12, so I need sine of capital B, and we need that to go there. Okay, so then I'm going to do my cross multiply. So 12 sine of 35 is going to be equal to 7.5 times sine of B. And if I divide that 7.5 over, okay, sine of B is going to be, sine of B is going to be equal to 12 sine 35 divided by 7.5. Okay, and I got 0.9177. And then if I take the inverse sine, come on. Oh, come on. I get B equals 66.6 degrees. Okay, now the 66.6 degrees is where they get this angle right here. Okay, so that's going to be for the big triangle, the overall purple triangle, 66.6 degrees. Okay, and then the way that they get this other angle right here, this 113.4, is if you take 180 and subtract 66.6, you will get 134.4. Okay, so that gets us our B for our other angle, 134. I should write this in green. 134.4 degrees. That's what he will end up being. Okay, so that's the relationship between those two. Okay. Yes, I hear you. Those two things will add up to be 180 degrees, those B's that we're solving for. Okay, all right, now they want us to find C, capital C and lowercase c. Okay, so let's see how we can figure out this. Well, if I look at capital C for this purple triangle, right? I have 35 degrees, I have 66.6 degrees. I can solve for that capital C. 35 plus 66.6, and I subtract it from 180. 180 minus that. All right, 35 plus 66.6, and I'm going to take 180 minus that answer. That's going to give us 78.4 degrees for this guy up top here. Okay, so that's my purple one, 78.4 degrees. Okay, if I'm going too fast, pause the video and you can write some of this stuff down. Okay, let me zoom out here. Now, if I want to find this small angle for that green colored triangle, okay, I would add 35 and 113. 35 plus 113.4, I guess. Okay, that's over here. And I subtract that from 180. And 180 minus 35 plus 113.4. Okay, and I get 31.6 degrees. That's what he is. Okay, we're getting close. 31.6 degrees. Now the only thing that I have to solve left is my lowercase c's. So lowercase c here, lowercase c here. Okay, so what I'm going to do is I'm going to set up another law of sines for each one of those. Okay. And they're going to kind of look very similar to each other. I'm going to use, instead of using 66.6, I'm going to use 35. Okay, so I'm going to do sine of 35. Okay, and then think about what has to go on the bottom. If I use sine of 35, what number will have to go on the bottom here? We will have to use 7.5 because we used A. Okay, and then I want to do sine of C here is 78.4, and I want to do my lowercase c in that case. Okay. All right, going to look very similar over here. I'm still going to use sine 35 and 7.5, but in this case, my C is 31.6. Okay, and I have my little c here. Okay, so cross multiplying on each one of them, I'm going to multiply these two together. Okay, and divide by sine of 35 to get what c is. All right. Same thing here. I'm going to take 7.5 times sine of 31.6 and divide by sine of 35 to get this c. Okay. So I'm just going to change some things around in here and get each one of those c's, and we will have an answer. All right. So here we go. Let's do 7.5 times sine of 78.4, that's this first one, divided by sine of 35, okay? And I get 12.81 is what this little c is, 12.81, okay? That's this length, all right? Now, that, again, is the length of this bottom side here, c, okay? So I know that my c over here for the green triangle should be something less than that 12.8. I have an annoying brother that keeps trying to call me. So 12.8 is all the way across here, but I know that the green triangle should be somewhere less than that. Okay, so let's figure out what that is. I'm going to go, since I have this all typed in, I'm going to go back up to my original equation. And the only thing that I've changed here is the 78.4 is now 31.6. Okay, so I'm just going to go change the 78.4 to a 31.6, and 6.85 is what he's going to be. Holy cow, what a crazy problem. Okay, so in that case, I have two solutions, and that's what my two solutions will look like. That's the basically all of the sides, all of the angles for both of those triangles if we separate them out. Okay, all right, so let's go to the back side. We're going to skip example 5 because it's just another one kind of like that. If you want to take a look at it, you sure can. I'm going to go down here to the area of triangles. Okay, I'm going to talk a little bit about where this formula comes from. The area of a triangle is 1/2 the base times the height. Okay. But they are saying when you have kind of an oblique looking triangle, this guy here, we don't have really a definite height. The height is kind of like this vertical height here, that dotted line. And like, how do we find what that is? Okay, the base is still going to be b. Okay, so I should still have 1/2 b, but this height right here, like, how do we figure out what the height is? Okay, so what they've done is to embed it into this formula. They've looked at this right triangle here, okay, and they are saying that if I look at this angle C, okay, and use basic SOHCAHTOA with H and A, okay, H is going to be the opposite side. The A is actually going to be the hypotenuse side. Okay, so I have opposite and hypotenuse, which is going to be sine. Okay, so I have sine of angle C is going to be equal to the H, the opposite side, over the hypotenuse side. Honey, go in the living room. I'll fix it here in a minute. Okay, and then to solve for H, if I multiply A to the other side, I have H will be equal to A sine of C. Okay, so when I'm talking about my height here, I can replace the height of triangles like this with A times sine of C. Okay, which will look like 1/2 base A sine C. They just wrote it as 1/2 AB times sine of C. Okay, so that's kind of where that formula comes from. It's still from the 1/2 base times height for area of a triangle. They're just saying the height can be written as A times sine of C. Okay, and then you just plug it in and you're good to go. So in example 6, they want us to find the area of this triangle. Okay, we have this 130 degrees, and we're going to call that our angle C, kind of like the formula does up here. Okay, so we're going to call that C. This would be little c. Okay, and then it really doesn't matter which one we call A and B, so we'll say that this is A and this is B. If we're trying to find the area, then all we have to do is 1/2 AB sine C. A is going to be 8, B is going to be 13, sine of C is 130. Okay, and then we just type that in and we can figure out what that area is. 1/2 of 8, I'm going to go ahead and do it in my head, that's 4. 4 times 13 is actually 52, so I could do 52 sine of 130. Okay, and this will give me an area of 52 sine of 130. That will be 39.8 units. Actually, 39.8 units squared, or centimeters squared. It does have units on it. Centimeters squared is how large that triangle is, okay? So you're still doing 1/2 base times height, except, you know, it's just kind of an altered formula. 38.8, or 39.8 centimeters squared, okay? All right, I'm going to go ahead and skip example 7 as well. Heron's formula, I don't think I give you an example like that on your homework assignment, but it is just the formula that you will use to find the area of a triangle if you're given just the 3 sides. Okay, and it's kind of big and ugly. So plugging those into here, and then they give you another formula for S. So you have to find S, this S in here first. I'm not going to worry about Heron's formula because I don't remember this formula. Anyway, I do kind of remember this formula up here, or at least where it comes from. So that's the important part. But Heron's formula, I'm not going to test you over. So we're going to skip that. So what you need to do for homework is finish this law of sines sheet 1 through 8. So 1 through 4 are going to kind of be the ones that we did together today and yesterday, where you're actually solving the triangle. So write out what A, B, C are for each one. And then 5 through 8 is just asking you how many solutions there are. You do not have to solve the solutions. So just tell me 1 solution, no solutions, 2 solutions. Okay, those are your 3 options. But that's what you're going to do for 5 through 8. What you need to do is when you are done with this, take a picture of it, like with your phone or something. Take a picture of the law of sine side, take a picture of the law of cosine side, and then you can either email that to me, or underneath of this assignment page on Google Classroom, there's a place where you can upload those. So I'd have them all in one spot. That's probably what I'd prefer you to do, but if you can't get that to work, by all means send it to me over email and I'll get that graded for you. But those 2 things, take a picture of them, send them in. Let me know if you are having problems submitting those. Also, I have a couple kids that have contacted me, not in Trig, but in other classes, that have said, hey, I'm really having a hard time understanding this. If that is you and you are struggling with something, shoot me an email and I can meet with you over Google Meets. We can like set up a video conference or whatever. It's super easy to do, and I can help walk you through some of these. Okay? All right, that's all I have.